Okay, here we go. We're gonna put some of the things we've learned already so far, and we're gonna switch it up a little bit so that we can have one more skill in our toolbox. Right behind me is a parallelogram, right? Yeah. And you may have noticed something a little bit different, because when we were looking at parallelograms before, I was basically giving you the height measurement and the base measurement, and we could use those two to find the area. We could find out how many square units were inside, but this time I'm actually giving you the area and the height, but I don't know this yet. What I want to know is what's the missing length of this parallelogram? What's the length of the base? Okay? So let's say that you have a very eccentric personality and you have a yard that is in the shape of a parallelogram and you know basically how much area it keeps up, and you know that from one end of the yard to the other is 6 feet. That's not very big. That's like a little patio. Okay? You want to know how long is this thing right here, so that you can make a nice little row of flowers. You want to know how many feet that base is, so you can go out and buy some potting soil, some flowers. I'm not a gardener, but let's say that we're trying to do something with our nice little yard here. So we need to know how long this is right here. How do I do that? Well, it all comes down to that area formula. Do you remember the area formula for a parallelogram? When you want to find area, the A comes first. And what do we do to find area? Well, we multiplied the base times the height. Remember that? We basically stuck the B and the H together to show that we're multiplying those two. But this time, I already know this, and I know this, and I'm trying to find this. Let me go ahead and fill in the things I know, just so we can see what it looks like. So here's A for area, but instead of A now it's 54, right? I don't know B yet, so I'm going to keep B there. And I'm going to multiply that by 6. Okay? Let me put this in a way that's a little more comfortable for me, because I'm used to putting the coefficient before the variable, right? So let me have 54 equals, flip these two because commutative property says we're allowed to, 6b. Oh, I've seen these before. I saw these when we were solving equations. This is a one-step equation. That's easy. Basically, if I want to get that b all by itself so that I know what the value is, I'm just going to divide both sides by its coefficient, because 6 divided by 6 leaves me with 1b, and 54 divided by 6 leaves me with 9. Make sense? Does that sound right? It sounds pretty good to me. So this base right here, this length right here, is 9 feet long. Okay? That's not too bad, right? Shouldn't be too bad at all. And basically, if you look at all the steps we took right here, when you boil it all down to one, trying to get it as simple as possible, what basically happened is I divided the area by the height. You see that? Area divided by height gave me base. And in fact, that's kind of a formula you can use. If you wanted to take a little shortcut, you could take this formula right here and say, okay, how am I going to get b by itself? Well, I'm going to divide both sides by h, right? Which would leave me with just b. But this over here would be a divided by h. So a little shortcut formula there would be, to find the base, I just have to divide area by height. However, I'm not going to get into that yet, okay? No shortcuts yet. I want you to take the time to go ahead and use the original formula and plug in the values you do know, and then try to solve for the values you don't know. Let's not worry about these yet. We're going to get plenty of practice with that kind of stuff in later math courses. But for now, I just want you to pay attention to what is it you know, what is it you're trying to find, plug in the values of the things you do know, and then solve for the things you don't. With me? Now, base times height is pretty easy. Parallelograms are friendly because there's really only a couple of steps you have to take with them. But what if I had a triangle? Notice I have this natural curve. That's pretty weird. But anyway, We also know, let's go ahead and write down the formula for a triangle's area. Do you remember that one? It was very close to a parallelogram because this is half of a parallelogram, right? So if I'm looking for the area of a triangle, it's basically the parallelogram, BH, but then it's half, so I have to divide it by 2. Remember that? Okay. Now let's say that I do know the area of this. Well, actually, I do know the height. I'm going to go ahead and say the height of this guy is 18. Whoop. And I also know that the area of this thing is, let's make it a crazy number. No, let's not make it too crazy. Let's say the area is 240. And let's pick a unit. Let's just say this is a drawing we're dealing with, and it's 240 centimeters squared for the area inside, and it's 18 centimeters tall, right? But what I don't know is this. How do I find that? Well, kind of the same thing we did before. Let's use the original triangle formula, put in the values that we do know, and then we'll find this one that we don't know. Okay, so rewriting, A gets replaced with 240. We don't know B, so we'll leave B alone. Okay. We do know the height, it's 18. And we're going to divide the whole mess by 2. Okay. Now before we start moving these two around, I want you to recognize something. If we look at this B times another number, and then we see this 2 in the denominator here, we can go ahead and divide right now. And I actually suggest that we do, because it'll simplify everything else, and more importantly, it'll get rid of the fraction. Okay, well, it'll get rid of this denominator. If I can put 2 into this number, I should. And I can, because 18 divided by 2 is 9, right? So if I rewrite this whole thing, I'm going to put it over here this time so it's a little easier to see. 240 equals, this is now 9, and this is 1. So now that this is 1, it doesn't need to be a fraction anymore, it's just B times 9. And since I don't like B9, or B times 9, I'm going to flip those two, because the commutative property tells me I can, and I'm going to rewrite that as 9B. Okay, can you see where I got 9B from? This is division happening here. So I went ahead and did this first, mostly so that I could clear this fraction. See? No fraction. Okay? Now, all I have left is the one-step equation. That I can get rid of this coefficient and just have B left over. And then I just have 240 divided by 9. I'm not going to be lazy and pull out my calculator this time. Okay, so I know 9 goes into 24 2 times, because that leaves me with 18. 14 minus 8 is a 6. 9 into 60 is 6, because that gives me 54. And then I'm going to bring down this number, and I can already tell that I'm going to have a repeating decimal. You see that? I have 60, I have 60. I'm just going to keep getting 60, 60, 60. So this is basically 26.6, and then it's just going to repeat. So I'm going to stop right here. And this 6 is going to tell me to round this number up to a 7. So the base is 26.7. Okay? Almost the same as the parallelogram. The only thing that we did differently was division to get rid of that fraction. If you can divide here, do it. Even if you don't think you can, let's say that this is not an even number, divide it anyway. It's better to have a decimal as a coefficient than to have a fraction right here. Go ahead and get rid of that fraction. Okay? You're going to see that again, because Same story with trapezoids. So here's the triangle. Now the trapezoid might have a few more steps. And I'm going to draw it so that we do take some more of those steps. Not because I'm mean, not because I like to torture myself, but because it's kind of important to see what happens when you don't know an important part of this, okay? So here's my trapezoid. Excuse me. And I know that for my trapezoid area, I need to know both the bases, because I have to add them together. Remember that? I have to add base 1 plus base 2 and multiply those by the height, this height, right? And all of this then gets divided by 2. It gets cut in half. Okay? Look familiar? You may have it in your journal with the H on the other side. Can you tell why I want to put it on this side? Usually when you look at a math textbook, they have the H on this side for some reason. But my reason for having the H over here is because if you do know these two, it leaves you with one number, which can then be considered the coefficient for H, okay? That's not gonna happen this time. But let's go ahead and figure this out. Okay, so now I'm going to say that this guy, this trapezoid, I already know has an area of, let's make a big number. Let's make it 780 centimeters squared. 780 little centimeters in this trapezoid, okay? Let's say that the height, this number right here, is 8 centimeters. So I know the height, and I know that this base here is 48 centimeters. You can tell obviously that my trapezoid here is not to scale. Don't worry about that. I'm basically just using it as a model. But here's what I don't know. I don't know the second base. And that may look scary because look what that second base is. It's like in there. It's like, it's trapped. How am I supposed to figure that out? Well, like I said, I could move this thing around so that I can find out what would B2 equal, what would a formula be for that, but we're not gonna do that till later math classes. So I want you to go ahead and just fill in the things you do know, okay? Let's rewrite that whole formula, but now let's write in the things that we know. We do know area, so we'll replace that. Inside the parentheses, I do know B1, it's 48, but I don't know B2. And I do know the height, right? Okay? And all of this right here on this side is being divided by 2. So far, so good? All I did was fill in all the things I do know. Now here's a nice trick. This whole sum inside of these parentheses is being multiplied by 8, right? This basically, if I were to change this math into an English sentence, what I could say is that it's 8 times the sum 48 plus B2, okay? But here's a cool thing I can do with this, because remember with the triangle, we wanted to get rid of that fraction, totally. I can't divide this by 2. I mean, I can, but it's not really gonna do me any good. It's gonna leave me with a big mess still. But what I can do is take this factor, all by itself, all by its lonesome, and divide it by 2. Okay? If I were to do that, 8 divided by 2 is 4, and that leaves a 1 down here. With me? Since this is a nice lonesome factor, I'm going to divide it by 2, and that helps me get rid of this fraction. There is no denominator anymore because it's just 1, right? So if I were to rewrite this whole thing, I would have 780 equals 48 plus B2 times 8. Let me draw a little line right here so we can keep track of what's happening. I'm sorry, that's not 8, that's 4 now. Yes. Gosh, that was the whole point, right? It's to turn this into, to get rid of this, so this is a 4 now. So see how that changed, and now there's no denominator. Now I think I know how to do this. Because do you see what's going on here? I have a factor outside of the parentheses here. There's a property I can use. Remember? Hasn't been that long. We can distribute this 4 to both things inside the parentheses. And that gets rid of the parentheses, that untraps, that unknown, okay? So I'm gonna go ahead and rewrite this one more time. I'm gonna say, what's 4 times 48? How many of you are doing these in your heads? Not me. 4 times 48 is 192. And 4 times b is 4b. All I did was distribute, right? Now look what I have. A 2-step equation. I'm good at these too. All right, so I want b to be all by itself. And I can't, the first thing I need to do is get rid of this constant. I need to move this constant. So basically to get rid of this, I subtract by that number. It's positive, so I'm going to subtract. But to keep the balance, remember? Same thing to both sides. Okay, so this goes away because it's 0. This is just simple subtraction. That gives me 10 minus 2 is 8. I need to borrow 1 from here. 17 minus 9 is 8. And 6 minus 1 is 5. And then over here I still have 4b. So I now have 4b equals 588. Now it's a 1-step equation. All I have to do is divide by the coefficient of b to give me area. I'm sorry, to give me b2. So what's 588 divided by 4? Well, 4 goes into 5 once. 4 goes into 18 4 times. 4 goes into 28 7 times. And that leaves me with a nice even finish. 147 is the answer of that division. And that tells me that B2, this second base, the longer base, has a value. Let me get my red so it matches. Of 147. Okay? All just using the original formula, figuring out what I do know, and then solving for the thing that I don't know. One of the new things that I kind of threw in here that I want you to practice in your practice exercises is whenever you see this kind of fraction happening with the triangle and with the trapezoid, get rid of that fraction first, okay? Even if that isn't an even number. Let's say that was 7, okay? Can you divide 7 by 2? Well, not evenly, but it'll get rid of the fraction and you'll now have a 3.5 here instead of the 4. You'll have a 3.5. And yes, you'll have to distribute that 3.5, but it's okay. It makes the math a little weirder, but at least you don't have a fraction. Having that fraction there messes everything up. You understand what I'm saying? Okay. I know these look kind of big and messy. Sometimes I think, man, I should get a bigger whiteboard. I should just draw on the whole wall. But hopefully you were able to follow this, okay? If you had a little trouble the first time, go back, rewind this video and watch it again. Make sure that you're following along in your journal. Now check out my exercises. I have an exercise sheet under there where I'm going to give you one problem for each shape and then a couple of problem solving. Meet me back here to go over that exercise sheet and then check the bottom of the screen for lots more practice. All right, so I'll see you in a bit. Try those exercises.